Hello, everyone. So today we're going to talk about Chapter 13, Altered Immune Response. So the immune response, it helps us by attacking invading organisms such as viruses, bacteria, fungi, and parasites, as well as cancer cells. Hi. Okay. The immune system can hurt us by attacking if a patient's had a blood and marrow transplant, and of course our own healthy cells. So skipping over to the types of immunity. So the human body, it resists foreign or non-self materials such as toxins and microorganisms by two major mechanisms, and that would be innate or acquired. So innate, that is present at birth, and this is also considered first-line defense. So neutrophils and monocytes are the primary white blood cells involved. With acquired, you've developed immunity. So with active, this occurs after exposure to the disease itself or to immunization, and it requires stimulation of the immune system. So an example would be maybe a child has developed chickenpox or they've received a vaccination. But with passive, it occurs when preformed antibodies are administered. A temporary measure and does not involve stimulation of the immune system. So this can occur naturally via breast milk to the infant, or it may be given after exposure to a disease such as hepatitis. It is short-lived because the person did not synthesize the antibodies and consequently does not retain memory cells for the antigen. So essentially, there are two basic types of immune responses. You have natural, that is considered your native or innate, as well as specific acquired. And of course we'll talk about that in another slide. So with antigens, these are foreign materials. It triggers a specific immune response and then becomes the target of that response. And as you can see, most are composed of protein. With your antibodies, these are protective proteins produced by the immune system, and antibodies bind to specific small regions of an antigen. So there's also some organs that play a role in the immune system. As you can see, a few that we're going to discuss, the lymph nodes, the tonsils, the spleen, and so on. So, like I mentioned earlier, there's two types of specific acquired immunity, and that is cell-mediated immunity, and the second is antibody-mediated immunity, and that's also known as humoral immunity. So, the immune system, it has 5 major cells. It has the lymphocytes, the B cells, your helper T lymphocytes, those are the CD4, and cytolytic and lymphocytes. So those are referred to as CD8 and CTLs. You also have macrophages and dendritic cells as well. So if you look at some of these organs, such as the thymus gland, that's located behind the sternum and in between your lungs. And of course, it shrinks with age. So the T cells, they're responsible for cellular mediated immunity. So the two major classes of T lymphocytes can be differentiated by the presence or absence of CD4 or CD8 surface proteins. T cells that contain CD4, these are your T helper cells. I also mentioned the B cells, and your B cells, they make antibodies. The CTL cells, they kill the target cells directly. The helper T cells that I mentioned, these are essential for the activation of B cells, CTLs, and macrophages involved in delayed hypersensitivity, and we're going to talk about that later. And of course, you have the bone marrow. The bone marrow produces red blood cells, white blood cells, and platelets. So the bone marrow orders the blood, but your kidneys, the bone marrows, they make the blood, but the kidneys order it, and the kidneys order blood through erythropoiesis. And if you remember, that's a hormone that stimulates those cells to produce in the bone marrow. As for lymph nodes, so when antigens are introduced into the body, they may be carried by the bloodstream or lymph channels to regional lymph nodes. Antigens interact with B and T lymphocytes. So the two important functions of lymph nodes is one, filtration of foreign material brought to the site, and two, circulation of lymphocytes. So the B cells, they're also known as bursa-dependent lymphocytes. Again, they're responsible for humoral immunity. B cells are distinguished from other lymphocytes to their ability to produce antibodies. You're familiar with your tonsils, the spleen that filters foreign antigens from the blood, and the lymphoid tissue associated with the gut, the genitals, the bronchi, and the skin. Those protect from external microorganisms. If you turn the next page, you'll see that chart. So with mononuclear phagocytes, one thing that I wanted to mention is that monocytes, they originate in the bone marrow and are the immature form of macrophages that live in circulation for about 3 days before entering tissue where they mature into a macrophage. And typically, let's say for instance, maybe 2 days you've been sick, maybe you've had a cough, a fever. If your doctor did a CBC on you, the monocytes, you would see an elevation. The monocytes come out into the bloodstream after 24 hours that patient has been sick. If it hasn't been 24 hours yet, you're not going to see that on the differential. So with your lymphocytes, again, produced in the bone marrow, they differentiate in between B and the T. So the B cells, these differentiate into the plasma cells, and when activated, they produce antibodies, such as your IgG, your IgM, and IgE, and so on. Back to the T lymphocytes, these cells that migrate from the bone marrow to the thymus differentiate into T lymphocytes, or thymus-dependent cells. The thymus secretes hormones, including thymosin, that stimulates the maturation and differentiation of the T lymphocytes. T cells compose 70 to 80% of the circulating lymphocytes, and they're primarily responsible for immunity to viruses, tumor cells, and fungi. So T lymphocytes differentiate between T cytotoxics and T helper cells. So with this T cytotoxic cells, that's your CD8. These cells are involved in attacking antigens on the cell membrane of foreign pathogens, and they release a substance that destroy the pathogen. Some T cells can become sensitized to an invader, and then they develop what is called the memory cell, and you'll see that on that chart. With the T helper cells, so CD4, they differentiate based on the type of cytokines they secrete. They secrete Th1 and Th2. And so with Th1, a lot of times patients, that's considered more of an autoimmune response. Th2 is considered, that occurs when actually the infant is in, or the fetus is in the mother's belly. So Th1 cells, these stimulate phagocyte-mediated ingestion and killing of microbes. Th2 stimulates eosinophil-mediated immunity. This is effective against parasites, and it's involved in allergic responses. So some medication that we give in my office, I gave a couple weeks ago. It was for a lady who had high eosinophils in the blood, and so they're in her lungs. So I had to give her what was called Nucala, and that's considered to be an IL-5. It's an injection, and it lowers the eosinophils in her lungs, so it prevents her having exacerbations from asthma. So moving on. So you'll see where you have that little chart. T cells 70 to 80, B cells are 10 to 20. Less than 10% are our NK cells. And as you see, they have no B or T cell markers. They can kill tumor, a transplanted graft, and virally infected cells without prior sensitization, so they can respond to a number of foreign invaders. You also have what is called dendritic cells, and they're found in many places in the body, including the lining of the nose, your lungs, the stomach, and intestine, especially in the immature state. They're found in the blood. Cytokines, I'm not going to say too much about them. These are proteins secreted by the white blood cells. They act as messengers that stimulate surface receptors. So an example of a cytokine as well, obviously there's many. Erythropoietin, colony-stimulating factors, and interferons, and other things such as interleukins. So to mention a few, interleukins, they act as immune modulatory factors. Colony-stimulating factors act as growth regulating factors for the hematopoietic cells. Like if you're giving Epigen, that increases the red blood cell count. We discussed that in pharmacology. And interferons, they're the antiviral and immunomodulatory. So interferons, they help the body's natural defense attack tumors and viruses. Tumor necrosis factor, These are mediators of acute inflammatory reaction to microbes. Colony stimulating factors. They're a substance that stimulates the production of blood cells. Such another example would be Neupogen, increases the white blood cell count. Erythropoietin that I mentioned, if you recall, again, that's a hormone. It's produced predominantly in the kidneys. So once that's made, it acts on the red blood cells to protect them against destruction. At the same time, it stimulates stem cells of the bone marrow to increase the production of RBCs. So, moving on to some cytokines. IL-1, clinically, that's typically used for rheumatoid arthritis. IL-2, it can be used for metastatic renal cell carcinoma or metastatic melanoma. IL-3, that's the hematopoietic growth factor. IL-4, that's mainly an anti-inflammatory mediator, stimulates growth of your mast cells. I mentioned your IL-5, that promotes growth and differentiation of eosinophils. And like I said, with asthma patients who have eosinophils, very high levels, we're giving them drugs such as like Nucala to combat that. So it lowers their eosinophils, and then their asthma is less likely to exacerbate. So I'm going to skip over the rest of the ILs, and I am going to head to you might want to look at there's a nice chart here where it talks about protection, humoral versus your cellular. So with humoral, I mentioned this is an antibody-mediated immunity. Remember, the antibodies are produced in those plasma cells, and they're differentiated into B cells. And so with cellular immunity, that involves antibodies that remain attached to the cell surfaces. So there's 5 classes of immune globulins, and each has a specific characteristic. So you have IgG. This is the most common type, makes up about 80% of all Ig. It's smallest, and therefore it can move into interstitial tissue easily. It's most commonly involved immune reactions to remove foreign invaders. Only Ig to cross the placenta and provide newborns with passive acquired immunity. IgA, this is made by the plasma cells in the skin and the mucous membranes. It's present in most body secretions, such as the saliva, tears, breast milk. And some believe if you have too little of IgA, you are more vulnerable to allergies. IgM, this is first made after contact with an antigen. It's the largest of the immune globulins. It's found in the plasma, and it has the greatest ability to activate the complement, which is a substance of humoral immunity that amplifies the humoral immune response. Only one molecule of IgM is needed to activate the complement, but 5 is needed of IgG. IgD, that's found in the plasma, that also stimulates B cells to multiply when needed. IgE, that's found in the plasma and interstitial fluids, causes symptoms of an allergic reaction. by signaling molecules to activate the mast cells and the basophils, and they release vasoactive substances. And we're going to talk more about IgE in one of our next videos. So I'm going to skip over a few of the slides. Just want to talk about macrophages. These clean up the debris after a phagocytic action, or the breakdown of tissue, and secrete growth factors for healing, such as fibroblasts. Macrophages are important for presenting a foreign invader to the immune system so that the immune system can recognize the invader and attack it, and it can live for months. So let's see if there's anything else here. I don't think there's really anything else I wanted to bring up with this PowerPoint. So the next video will be altered immune response.